So the topic for this particular video will be Dependency Inversion Principle, or DIP. Now this is the D in the solid principles that we are currently studying about. First of all, let's understand the definition of Dependency Inversion Principle. Quick disclaimer, the definition is going to be confusing. It has a lot of things you might not understand at the first go. So please stay with me till the end, because I'll be taking a real life example. I'll be breaking the code down and I'll be explaining you the definition line by line. So please stay with me till the end. Let's read through the definition. High level modules shouldn't depend on low level modules. That is the first saying of the definition. The next one is both high level modules and low level modules should depend on abstraction. Okay. Third is abstraction shouldn't depend on details. Abstraction shouldn't care about what is being implemented underneath it. At the same time, details should depend on abstractions. Whatever abstraction is saying, the details should be doing it. Okay. Again, as I said, the definition is confusing. Do not worry. Now I'll be taking a real life example in order to explain you dependency inversion principle. So I'll take the example of recommendation algo. You must have seen in Netflix, in Amazon Prime, and YouTube, you have different kind of recommendation algorithms working for you. So we can have something as a recent recommendations. We can have something like a trending recommendation. We can have something like a genre-based recommendation. Now, for a service like Netflix, for Netflix, whenever they're showing user the content, they could literally use something like a recent. They could use something like a trending. They could use something like a genre-based. And depending on whichever is performing well for a certain user, they're going to push it much in a much bigger sense. Why? Because the revenue will be more. If the user is watching a content, they get paid more. So that is why they can have multiple kind of recommendation algos, and they can keep switching between this, and any new recommendation that they are bringing across. Now, the recommendation algorithm could be working on the home page, could work on different pages as well. So that is the use case, that is the problem statement. Now, if I have to write code, how will I write code? Forget about dependency inversion principle as of now. I'll go ahead and I'll say, okay, class trending recommendation, and I'll be like, I'll just write it void, or maybe public void recommend, and that's my code. That's for trending recommendation. Similarly, I'll go ahead and I'll write it for genre as well. I'll write it for genre. And if Netflix is using it, imagine inside the main, Netflix is using it. What Netflix will do is, What Netflix will take trending recommendation and create an object of it, and will straight away say trending recommendation dot recommend. And the recommend will have the logic. It's going to recommend what kind of movies or what kind of series to watch. Now this is fine. This looks absolutely fine. Now imagine tomorrow we introduce one more recommendation algo, and that is something like recent. Now over here, what I've done is public void, instead of defining it as recommend, defining the function as recommend, I'll say recent recommend, because there is no layer that is forcing me to define it as recommend. Now what will happen is, if Netflix has to change the algo, it will have to change everything. Recent recommendation, a recent recommendation over here, a recent recommendation over here, a recent recommendation over here, and this one as well. And this becomes such a nightmare, because they'll have to change it at they'll have to change it at so many places. And this is a very small level of code that I'm showing you. There can be multiple such things, and that is an issue. Now what's happening over here? And this is your low level module. This is your high level module, because you're kind of using a class to do something. Now over here, if you carefully see, can I say that the high level module is depending on the low level module, because the low level module changed the functionality to recent recommend, so it had to change the call. So the high level module and the low level module are very tightly coupled. So if anything changes underneath, everyone that is using the recommendation stuff will have to change it, and that is tricky, and that shouldn't be done, because as your code scales and the code is being used by multiple microservices, you will face issues. So that is why the next thing comes up, that is, in the definition, you understood now why high level and low level shouldn't be tightly coupled. They should depend on abstractions. Now, what do I mean by this? They should depend on abstraction. Let's understand the definition. So what I could do is, I could go ahead and say, I'll have an interface and I'll say recommendation strategy or something like this. Okay. And in this, I'll say void recommend. My bad. Void recommend. Perfect. So what I've done is, this is kind of the interface, which is the abstraction layer. And I'm saying that we'll have a recommend over here. And I'll make sure everyone implements this while I'm writing my code. Implements recommendation strategy. I'll do it. So tomorrow, whenever a new low level algo is coming up, like recent, it will throw an error. Why? Because we will have to make sure that the recommend is implemented. So the tight coupling is gone now. Now, instead of directly using the low level module, now what we will do is, we will be like, okay, hey, can I use the recommendation strategy, the abstraction, and then this, and then this, my bad, new recommendation strategy, no, new, any of the recommendation that you will be using, your trending recommendation, and recommendation strategy will just call recommend. Now, are they tightly coupled? No, they're not tightly coupled. Tomorrow, if a new recent recommendation algo is being integrated, all you need to do is, you need to make sure you change it, and we are good to go. Dependency inversion principle. Understood this? So what I've done is, both are depending on abstractions. If you carefully observe, the low level module is also following the abstraction layer. It's implementing whatever is needed. And at the same time, the high level module is not very tightly coupled with the low level module. It's directly dealing with the abstraction layer. Now, what I could do is, this is my recommendation strategy. Now, I could go ahead and separate it out. I will be separating the recommendation algorithm all across. What I'll do is, I'll say class recommendation algorithm. The algorithm will be separated out. And over here in the algorithm, I'll say, hey, which kind of recommendation strategy will you use? So it's going to be like recommendation strategy. Okay. So whenever someone is going to use the recommendation algorithm, so what I'll do is recommendation algorithm, and I'll write a default constructor, which is going to take a recommendation strategy and a recommendation. And this will do this dot recommendation strategy. So whenever someone is using the recommendation algorithm now, they'll have to tell me that, hey, this is the recommendation strategy that we will be using. So there is an error. Let's quickly see it. Return type, my bad. We'll have a public and a void. Oh, my bad. This will be public. Yeah, I think the constructor, we are fine to go now. So what I've done is, I've created a default constructor with the recommendation algorithm. Now, what will happen over here is, I will be, instead of using the recommendation strategy directly, I will be using the recommendation algorithm now. Recommendation algorithm, my bad, recommendation algorithm equal to new recommendation algorithm. And over here, I'll say, do I need the trending? If I need the trending, I'll just pass on the trending. And the recommendation algorithm works on whatever you want it to return. And the recommendation algorithm will have the recommend function. So what I could do is public void recommend. And over here, I could typically make it recommend something like recommendation strategy dot recommend, whatever is the algo. you can have the logic. So what I've done is I have now decoupled the high level layer with the low level layer. So I can say that now this is my high level layer where I'm using the recommendation strategy, but I don't know which kind of recommendation strategy. That is something which is being controlled by whoever is going to use the recommendation algo. So if you look at this piece of code, it's nowhere interconnected. The recommendation algo doesn't know which kind of recommendation strategy to use, isn't it? Because that is something which is going to be controlled by the person who is going to use it. The Netflix homepage is going to use it in a different way. The Netflix some other page is going to use it in some different way. Now this is something that Netflix can decide depending on its use case. For 50% of the users, it's going to show trending. Maybe after 6 p.m., it's going to show you something like a recent. Depends. They can decide, right? So what I've done is I've removed the tight coupling. Now let's read the other part of the definition. The other part of definition is abstraction shouldn't depend on details. So if you look at the abstraction layers, this is one of the abstraction layers, I can say. It doesn't know anything. It doesn't know anything about the recommendation strategy. Similarly, this is an interface. This is an abstraction layer. It just knows that there is a recommend that has to be implemented. It doesn't know the details about it. Understand, they are not aware of what kind of thing is happening inside the recommend. Understood? So they shouldn't depend on the details. But the details should depend on abstractions. So if you look at the details like recent recommendation, genre recommendation, trending recommendation, they'll have to implement recommend. They can't run away from it because they're implementing the recommendation strategy. So they'll have to implement it in some way or the other. Understood this? So that was about DIP. I hope you understand the definition now. You'll have to make sure that they're not tightly coupled. And the only way you can do is use them through abstractions. So now I know the definition. I know the real life example as well. Perfect. What are the benefits of DIP? I think you know it. First of all, it's very loosely coupled to the interface. Tomorrow, if you want to change it, you can change it, right? If I go back to the code, and if you see over here, the recommendation algo is kind of just giving it the recommendation that it wants to use. Anywhere do you see the recommendation strategy over here? No, you don't see it because it's inside the recommendation algo. Tomorrow, if you want to change the interface, you can change the interface, right? Because it's very loosely coupled with the interface. Perfect. Next, just add new implementation. You want to add new recommendation, you can add and you can just change it wherever someone wants to use it. Easy to mock unit test. Obviously, if the code is modular and everything is a separate entity, you can always easily test it across. Abstraction controls flow, pretty understandable. No one is tightly coupled. Everything is controlled through abstraction. There's a separate service as recommendation algo that does everything for you. The only thing you tell recommendation is what kind of recommendation you are wanting to use. Fully open closed. Obviously, open close principle is followed because I'm not modifying any existing class. I need a new functionality. I add a new class and make sure it implements the recommendation strategy. Simple as that. So those were the benefits of DIP or dependency inversion principle. With that, we have covered up the entire solid principle. So yeah, that will be it for this one. Thank you so much for watching. Let's meet in the next one.